All right. Okay, so let me get the Desmos now. Here we go. Here it comes. And again, for Desmos, you can get that normal distribution. You just type, as I'm doing, NORMALDIST, parentheses. I mean, you could leave it alone because it thinks you're working in the standard normal distribution, okay? Or you could just type in 0, 1. You could actually type in the mean and standard deviation from the word problem, which is 33.5 and 5.6 for the mean and standard deviation. And then you can calculate these percentages. But let me just do it this way with the z-score. Okay, so, I mean, again, I'm not going to say use Desmos. So I will give you that table from the textbook. Okay. But you could use Desmos. I think Desmos personally is a little bit easier to use than the table. But anyway, let me get back to the z-scores. So we have, for the part A, right, it was to the left of negative 0.625. Right, to the left of, we have to click also this CDF thing, cumulative probability thing. So for the first one, to the left of negative 0.625, we actually get this number, which is a little more accurate because we had to round, right? If we had negative 0.6, this is what was in the table. The more accurate answer, though, is this. For part A, this would be the area, and the percentage then would be just converting this to a percentage, which is 26.5985 whatever percent. For part B, it was to the left of 1.1067. I think that's what it was. Let me check. 1.1607. Sorry, my mistake. There we go. And this is what we would get actually. In the table, we had to round to 1.2, and this is the number we get. From the table, that is. It's the same number. I think it's rounded off. A more accurate one is when we actually type it in. Now, if you want the area between the two z-scores, we have the bigger one listed, right? Let me zoom in a bit. And for the other one, it would be negative 0.625. So using Desmos, right, we can actually get the answer. We don't really have to subtract, but we get this. Okay. All right. Okay. All right, so this is what we get here. So let me do another problem. I mean, originally I was going to have you guys try it. Excuse me, have everyone try it. But since we're doing this right after break, you know, before break is when we were dealing with the lecture on this. Let's do it together. So let me get back to the notes. Okay, here we go. Oh, wrong button. There we go. No. Yeah, this one. Okay, so this is actually another word problem from the textbook. I don't know if I'm pronouncing this word right, but I think it's systolic. But the systolic blood pressure of males, they tell us, has an approximately normal distribution with a mean of 125 millimeters and standard deviation of 14 millimeters. So they're basically telling us that they measured the blood pressure of, I don't know how many males, but they did, but a bunch of them, I guess. And when they plotted the data, they saw that the data is approximately normally distributed. That is, it lies on a normal distribution curve, one that has a mean of 125 and standard deviation of 14. So what we can do first is, let's find the percentage of males that had such a blood pressure, a systolic blood pressure, less than 140 millimeters. So percentage of males, right? We're going to use z-scores, but we want to get the area to the left of a certain z-score. So we're going to get the z-score for 140 first. Okay? That's what I'm doing here. Then we get the area to the left of that. So when you get the z-score here, again, you subtract the mean and divide by the standard deviation. And that gives you this, 1.0714. Now, to use the table, we would round to 1.1. Let me show you, actually. Let me go to the table. Okay, I know it's annoying. I got to stop sharing, then share again. It's, oh, boy. Crazy. Here we go. Here it is. It's coming in. There we go. So, again, it was 1.017, I think I just said. Let me double check. Yeah, 1.0714. 1.0714. But that's not on here, so we rounded it to 1.1. And we get this. So the area to the left of that z-score, it's about 0.8643. It's about 0.8643, as you can see. Okay, so let me get back to the notes. Okay. So that was the area to the left. And so that tells us the percentage of data values less than that z-score, which is what we're looking for. It's about 86.43%, 86.43%, approximately. Okay, it's approximately that. All right. Approximately. All right. So that's what we get here. So now the question here. So for the next part B, what about less than 130 millimeters? It's really the same question, except instead of 140, you use 130. So your z-score is going to be different. You know, again, you subtract the mean, divide by the standard deviation, and you end up with this. So again, here, let me show you. I'm using the formula here. Subtract the mean, divide by the standard deviation. That's what I'm using here. So this is what I get. Now, I'm not going to go back to the table, but if you use that table, you would have to round to 1 decimal point. And you would get 0.4. And then from the table, it turns out the area is this. What the heck? Let me show you. I should show you guys. Let me do that. Okay. But if we rounded to 0.4, we would get this, 0.6554. So that would be the area under the graph to the left of this z-score. And going back to the notes again. Boy. All right. Hopefully I'll... Here it comes. 1 second. Here it is. Okay, so going back to the notes again, from that table we get this. And again, you convert to a percentage. So this is the area to the left of that z-score. And that's what we were looking for. So in this case, the percentage of males who had a systolic blood pressure less than 130 millimeters, okay? Less than that. What we found was we got the z-score. The area to the left of that z-score is approximately this. So the percentage of males then, the percentage of data values less than 130 millimeters is about 65.54%.